Okay, so let's see this question. This question came in GATE 2012 for 2 marks. The question is, how many onto or surjective functions are there from an n element set to a 2 element set? So there are two sets. So this is set A, this is set B, and the function is from A to B. And they're saying that the let's say one has an element set where one is an element set where n is greater than or equal to 2. So it is something which is number of the cardinality of A is something which is greater than or equal to 2. However, the second set, it is having exactly 2 elements. So there are just 2 elements. Now, so here cardinality of B is simply 2. Now they are saying that how many onto or surjective functions are there. What are surjective functions? Surjective functions are those functions where all the elements in the second set, the codomain, if each one of them it at least has one pre-image. Okay, so it cannot be that everything is mapped to just one and this one has this element has no pre-image, or this element has no pre-image and everything is mapped to this. That cannot happen. So in order to solve this question, a better way will be just to find out all the functions which are possible and then just filter out the cases which are not surjective. Okay, because we have to find the surjective functions. So we can see that total number of functions, if this is n and this is m, then you might be knowing the total number of functions is simply m raised to the power n. Okay, why? See, if let's say this can be mapped, so each function in the set A can be mapped to exactly 1, because that is the definition of function. So definitely this can be mapped in how many ways? 2 ways. In general, if m elements are there in the second set, then this can be done in m ways. So m ways this can be mapped. How the second element can be mapped? Again in m ways. Third element again in m ways. So in that same fashion, this will be how many times? N times, because this is the size of A. So now you get it that now it will be m raised to the power n, which I told you. So our point is that in this case it is going to be m raised to the power n, and m value is what? 2 here. So overall in this case our answer is going to be 2 raised to the power m, but this is not our answer as asked in the question. It is actually the total number of functions which can be defined on such a setting. Now we have to only find the number of onto functions. So let's figure out what are the functions which are not onto. So one example of a function in this setting, okay, so let's do it here only. So if everything is mapped to, let's say, just one element, and the second element is everything is mapped to just one element, and the second element has no pre-image, then this is not an onto function. Okay, and the second situation again will be if everything is mapped to the second element and first one has no pre-image, right? So these are the only two cases where the onto function definition is violated. So that one is not onto, and rest every in each and every of the rest of the cases, what is going to happen, that some of the elements are going to be mapped to this and the rest of the elements are going to be mapped to this. So they are all onto functions. So 2 raised to the power, okay, so this is 2 raised to the power n, sorry, so m value is 2, so and this n value is still n only, so 2 raised to the power n minus 2. Okay, so 2 raised to the power n is the total number of functions, and these two functions are not surjective, and therefore our answer is going to be 2 raised to the power n minus 2. Okay, so the correct answer is C, 2 raised to the power n minus 2.